Welcome geometry students to class today on this Monday the 5th. Hope you guys are doing well. Hope you're ready to learn some math today. Let's take a look at some announcements here. You will have a test next Tuesday. Now, let's put this into perspective for you seniors. Haley, I know that you're not a senior, but you other 4 students are. This is the day before your last day. So next Wednesday, congratulations, is your last day of school. Now, you are to come to class on Wednesday. We are going to go over your test, and we're going to do a review that you guys are going to have to take notes on Wednesday and turn in for a grade, okay? Remember, there's nothing mean about that. School goes until Wednesday, so you need to come to school all the way until Wednesday. But you will have a test next Tuesday, which means you will have a review sheet the day before on Monday, okay? Now, you were given homework on Friday, and here it is. Page 604, 10 through 18, 19 through 25, odd, and 30 through 39 all. Azu, Jasa, you guys turned this in already, so you're totally fine. Don't worry about it. But Jake, Martin, and Haley, you guys are not behind, but this is due today. So please turn that in now. If you don't turn it in today, I will, of course, email your parents like I always do. Now, Martin, you were out of town, so hopefully you're getting caught up on everything. And if you need me to email you any videos, like which ones you missed, I can email you everything you missed. For a whole week or whatever you need. And then Martin, quiz by Friday. You missed a quiz on Friday, so I'm giving you 1 week. You have until this Friday to make it up. I would take it as soon as possible, but you do have to make it up by Friday. Having said that, let's jump into this. I hope you guys had a good weekend. Hope you had a good weekend. Hope you're ready to learn some math today. Congratulations to the Berean soccer team, by the way, on their second place finish in the state. I think last year they won 2 and they lost 14. And they've had a really good season this year, so congratulations to them. Martin, you and the guys played a very tough Temple Pal team and battled them very competitively. I was really, really proud of how you guys played. I felt like I won't comment on these guys right here, but I will just say that you guys played really well, and you played very classy, and I was very proud of you guys. And to lose 1-0, boy, it was a close game, and you guys could have very easily won it. So congratulations. Could have gone either way. Okay, your quiz grades are posted on Sycamore. So if you're wondering what you got, look on Sycamore. I will pass them out and go over your mistakes once Martin has taken his quiz. Okay, so no pressure on you, Martin. I'm just saying once you've taken that quiz, we will go over the quiz in class. Now we're going to take a closer look today at diameters and chords. Now don't forget what a diameter and a chord, what they are. Now you know what a diameter is. A diameter is a line that, a segment that one end point lies on the circle. It goes through the center of the circle, and the other end point lies on the circle. So I just drew a diameter for you. But you know what else this diameter is? This diameter is also a chord. Okay? Any segment that has one endpoint on the circle and travels inside the circle and has its other endpoint on the circle is a chord. Any line that you want to draw that has one endpoint on the circle and its other endpoint on the circle, like this, that is a chord. So not all chords are diameters. Like this chord right here in red, that is not a diameter. But this chord right here that I'm coloring right now, that chord is a diameter. So all diameters are chords. Okay? If you have a diameter, it will be a chord. But not all chords are diameters. You can have a chord like this one right here, and this is obviously not a diameter because this chord does not go through the center of the circle. Okay? So I just want to quickly remind you what diameters and chords are. Okay? With that in mind, let's continue on. Your heading today is called Properties of Arcs and Chords, and the lesson number is 11.4. And again, as I mentioned earlier, the date today is the 5th. All right, May 5th, 2014. All right, we will be looking today at 2 different theorems. Okay, 2 different theorems. Here is the first one. Now if you want to view this theorem, then turn to page 608 right here, and you can see this theorem in your book. You don't have to, but you're welcome to. And here is what the theorem says. If a diameter of a circle is perpendicular to a chord. If a diameter of a circle is perpendicular to a chord, then the diameter does two things. Did you get that? It does two things. It bisects the chord and it bisects the arc. So let me give you a picture of this. Are you ready? Here we go. Here's a circle right here. Here's a circle for us right here. Nice big circle. And let's say we have a diameter right here. All right, here's the center of the circle, and here's my diameter. Okay. Now you can take notes on this or you can just watch. I encourage you to write this down, but you don't have to. That's up to you. All right. A, B, C. And now I'm going to draw a chord like this in green. I'm going to draw it right here. Put an endpoint here and an endpoint here, and we'll call this segment DE. Segment DE. And then I'm going to put a right angle symbol right here. Now, would you please listen to me carefully? Please, students, listen to me carefully. I don't like that right angle symbol, so I'm going to do it again so it looks a little better. There we go. Now, please listen to me, students. Look at this theorem. If a diameter of a circle is perpendicular to a chord. So here's what you need. You need two things. Are you ready? Take whatever side notes you need to. You need two things. You need a diameter, and you need the diameter to be perpendicular to a chord. Let me say it to you this way. You need two things. You need a diameter and a chord. I'll call that one thing. You need a diameter and a chord, and they have to be perpendicular. Let me say that again. You need a diameter and a chord, and they have to be perpendicular. Now, when that happens, let's use numbers to make it easier. When that happens, this segment right here that I'm kind of squiggling on right here, that segment right there will be congruent to this segment right here. So I'm going to give them numbers. I'd like you to write some numbers down. We're going to say this has a length of 5, and we're going to say this segment here has a length of 5. Got it? There we go. Now, let's say that this arc right here, and I'm going to do a little squiggly mark on it. Let's say this arc from here to here, that arc, is also going to be congruent to this arc over here. So let's put some numbers on it so we can see it. Let's say this arc here is, we'll call that 50 degrees, I guess. Let's say arc DC has a measurement of 50 degrees. Then arc CE also has a measurement of 50 degrees. Now let me go over this again. Please listen to me. If you have a diameter and a chord that are perpendicular, if you have a diameter and a chord that are perpendicular, the diameter will cut the chord right in half. So if this length here is 5, then this length right here will also be 5. And if this arc right here that I'm squiggling on is 50, then this arc right here will also be 50. So if a diameter and a chord are perpendicular, then you will have these congruencies, okay? And that is what Theorem 11.4 is saying. Let's look at 3 problems that will help us apply this theorem. If you want to, instead of copying this, circle in your notes, if you just want to write down where the problem is and then just take notes, that's totally fine. You will find this problem on page 608, and it's called example number 1. And notice we're looking for the segment of BD. Now, B, I'm going to highlight it in red for you. Here is B. If I can get red to work, there we go. Here is B down here, here's D right here. So endpoint, endpoint. We're going to find the length of this entire red segment right here. Okay? That entire segment. Got it? Now, do we have a diameter and a chord? Yes, we do. How do I know this is a diameter? Because it goes right through circle E. Plus it tells us in the directions diameter AF. If we read the directions, for example, number 1, it says circle C. I think I called it E, sorry. Circle C, center C, has the diameter AF. So with that in mind, yes, I definitely have a diameter, and it's right here. Do I have a chord? Yes, BD is a chord. So I have a diameter and a chord, and look, they're perpendicular. So as soon as I see that, I know this arc right here, FD, is congruent to arc FB. And I also know something else. I know that segment DE is congruent to segment EB. So think about it. If DE is 5, then BE also has to be 5. So the length of this entire segment from D to B has to be 10. So there's your answer, 10. The length of BD is 10. Not too bad. Let's try another one. You can copy these down, or you can just make note in your notes that we're getting these from page 608, numbers 1 and 2 at the bottom of the page. Okay, notice on number 1 here, we're looking to find the length of JM. Well, here's JM right here. There's JM. So we're trying to find that length. Now I have a question for you. Do we have a diameter and a chord? Yes, we do. Here's your diameter, and here's your chord. Are they perpendicular? Yes, they are. Here's your right angle. So anytime you have a diameter and a chord, they're perpendicular. This arc here, HK, will be congruent to KJ, KJ, and HM will be congruent to MJ, or JM, however you want to say it. So if HM is 12, then MJ is also 12. And that's what we're looking for, the length of JM. So the answer would be 12. Let's try this one over here. A little redundant, but let's try one more, okay? Find the length of SR. So we're trying to find the length of this entire chord, SR, okay? Now, do I have a diameter? Yes, I do. Do I have a chord? Yes, I do. Are they perpendicular? Yes, they are. So I know arc RQ is congruent to arc SQ, and I know segment SN is congruent to segment RN. So I know if RN is 15, then NS has to be 15 also. So if this segment here is 15 and this segment here is 15, then the entire segment altogether excuse me, has to be 30. Okay? It has to be 30. Well, I hope that makes sense, okay? So that's the first theorem we're looking at today. Now, the other theorem we're going to look at in a second is the opposite of this, and you're going to see that in a second. They're going to say in a second, if you have two chords that are perpendicular, then one of the chords has to be a diameter. No, I don't think. I think they say. Well, we'll take a look at it, but it's the opposite of this, or the inverse. Here is the second theorem for today. Now, if you want to make note of this, I didn't write this down. Why, I'm not sure, but you can find this on page 609 in your books. And let's read through this, okay? If one chord is a perpendicular bisector of another chord, then the first chord is a diameter. So let me go ahead and copy this in your notes, and while you're copying it down, or while you are copying it down, I'm going to give you a picture of this, okay? So pause the video if you need to, and make sure you're all caught up, okay? We're going to call this circle A. Actually, we're not. I don't want there to be a center because I don't want you to know that we have a diameter, okay? So no center. Okay? We're going to call this chord. Let's see here. We'll call it chord JA, I guess, for Jasa Allen. There we go. And then we're going to draw another chord. We'll change the colors, and we're going to draw this chord right here. And I guess we'll just use another J name. We'll call this, oh, we can't, that's right. So we'll go with H for Haley, and I guess A for a zoo. So there we go. All right, now can't use A, can I? Nope, we'll have to use M for Martin. Now listen, guys, please watch this. Do I have two chords? Well, it's obvious I do. I mean, this is a chord. I have an endpoint here, an endpoint here, and my segment. That's a chord. I didn't say it was a diameter. It's a chord. Now, obviously I have a chord right here. Here's the endpoint. Here's the endpoint. Here's the segment. So it's obvious I have a chord. Okay? I have two chords here. I have two chords. Now, if I were to do this, if I were to put a right angle symbol right here, okay, and then put one mark here and one mark here, that means, please listen to me, that means that JA is a what? It is a perpendicular what? Bisector. Now, if you have forgotten, let me get a drink here real quick. If you have forgotten what a perpendicular bisector is, let me refresh your memory. It is a line that is perpendicular to another line, and it also cuts it in half. Let me say that again. A perpendicular bisector is a segment or a line that is perpendicular to a segment, and it cuts it in half. Does this red line cut the blue line in half? Well, you know it does, because if I put a mark here and a mark here, that means we'll call this B. We'll call this point B. If I have a mark here and a mark here, that means that HB is congruent to MB. And if those two segments are congruent, then that means B must be right in the middle. So JA cut HM right in half. Now, did HM cut JA in half? Not at all. Look at this little segment right here. Look at this big segment over here. No. But we do know that JA cut HM in half. And what else did it do? It also formed a right angle. It's perpendicular. So when, are you ready? When you have two chords, are you listening? When you have two chords that are drawn in such a way that they are perpendicular and one chord is cut in half. Let me say that again. When you have two chords that are drawn in such a way that they are perpendicular and one chord cuts the other chord in half, then this chord right here, the one that is cutting the other chord in half, that chord right there is for sure a diameter. It is for sure a diameter. So now you know that this JA goes right through the center. Now you know that, and we'll call that center C. Okay? So let me say it again, and then I'm done for the day. Short video, not a long video, but you've got your work cut out for you. You need to do your homework. I've definitely gone slow. Last week I went slow. We did a lesson one day, homework the next day. Today I'm cutting lesson 11.4 in half, and I'll tell you why I'm doing that. It's not because it's so long. It's just a lot to learn. There's one more theorem in lesson 11.4, and we're going to cover that tomorrow. And that theorem is a long theorem, so I did not want to cram that in and give you homework. So I'm trying to go a little light here toward the end of the year, okay? And now I've lost my train of thought like an old man that I am. But I think what I was saying is I want to go over this one more time, and I'll give your homework to you. But again, if I have two chords and they are perpendicular and one chord cuts the other chord in half, then you know you have a diameter. Okay? Now the other thing we learned today was the opposite of that. We learned that if a diameter, you must have a diameter and you must have a chord. If you have a diameter and a chord and they're perpendicular, if you have a diameter and a chord and they're perpendicular, then you know these two segments are congruent and you know these two arcs are congruent. Okay? And so that's it for today. Now, I need you to really work on your homework. Do a great job. Here it is. Let's see, there's 3 problems here, 4, 5, 6, 7, 8 problems total. So you're probably going to be done before the class period's over. If that's true, work on something else. If you forgot to do your homework over the weekend, work on that and get that done and turn that in before you go today. The video, if you need to watch the video to help you with this homework, it would be Geometry 11.4 homework. Okay, that's the video you would want to watch to help you with this assignment if you need help. Okay, please do your work diligently. Please stay on top of your work and call or email if you have any questions at all.